And so, per the topic, per the schedule, we're going to be talking. I'm going to be talking about COVID-19 response in Africa, kind of broadly, and I'm hoping to avoid a little bit getting into the gory details for particular countries because we only have so much time, and I don't want to steal too much thunder from the other speakers. But I'm hoping to sort of set the stage for them. Okay, so I want to talk to kind of three big things about Africa, and that's going into a little bit more detail about what we know currently, and I think this is going to expand on what Caroline was talking about earlier, and then I'm going to talk about how we can use what we do know to make some useful models. And then kind of what are the sort of big missing things that we would like to know to make those, to improve our certainty about the model. So I'm going to put out there some questions about what we do and don't know, and kind of how those have consequences for the modeling efforts that we've done so far. Okay, so what we know. As Caroline mentioned, like the framing of this presentation is about Africa, but of course, Africa is not a place, a single place. It is a collection of many places, and indeed places even at finer resolution than what you see here. So this is a similar picture to what you were just shown. It's at a slightly higher resolution. We're ticking off some of the places that now have, now are past the 10,000 case count. I think that's only South Africa still, but Egypt may have caught up. So as you can see, there's some interesting heterogeneity here. And one of the things that we want to think about is why is that from what we can actually know about that. So one element is certainly different population sizes, but another element is probably early introduction times. And I remember back in February and March, sort of looking at the Africa CDC Twitter and the WHO Afro Twitters, talking about how they had done this number of tests and still had no confirmed cases, So I was just sort of constantly waiting for the other shoe to drop. And then it did in kind of late February, early March timeframe. So this is a picture of when, relatively speaking, when countries got to 10 cases, got to 10 confirmed reported cases. And you can see here, they're sort of the big early ones, Egypt, South Africa, Algeria. And those correspond to kind of where at least some of the locations today where we're now looking at having the most cases. So a little bit of the story is about early arrivals. But of course, not everywhere in here that had those reporting early cases is now reflected in what we think of it as places that are well along in their epidemics. Now, some of that is no doubt due to early reporting issues, but some things there may be elements of genuinely delayed introductions. And we have some other evidence about that. I was sort of legitimately waiting for the other shoe to drop. I thought that commercial activity between Asia and Africa was going to bring much earlier introductions than it appears to have. And this is kind of consistent with the story that's available from some of the phylogenetic information. Now, a huge caveat on that, there isn't a whole lot of phylogenetic information currently. There are only, say, like a handful of countries that actually have sequenced a relatively large number of cases. But for the most part, it looks like what we're talking about lineages-wise are mostly associated with the lineages that are in Europe primarily. So it seems like Africa sort of missed maybe early introduction from Asia. And we can talk in a little bit about why that might be, but was eventually, inevitably got it based on trade and travel with Europe. Maybe, again, heavily caveated because the relative, how sequencing is done, how the data is collected, the amount of it that there's available. Okay, and then so we can sort of look at, well, that was maybe the first 10 cases, what's going on with the first 100 cases. So this is a somewhat similar story for the first 100 cases, but now you'll see that there are a number of places which are not yet reporting 100 cases, and some of those I think have reasonable explanations. Some of them I think this really points towards some surveillance issues. But I want to call your attention, and is my little red dot visible? Yeah. All right. So here's South Africa, Egypt, Algeria, Tunisia, Morocco. These are some of the early introductions, and of course they're also hitting 100 cases quite early. But one of the other countries we're gonna talk about here, Kenya, we've got maybe something slightly different going on. So we'll go to that. Now we can start to, they're starting to become available in a nice sort of clean, consistent, comprehensible by a single person or a small group of people, rather than distributed in each of the individual locales, some information about what's been going on with interventions. And I know that I think Oxford was kind of an early mover on this government policies collection. There's now a 2B data set from the WHO that I know LSHTM is very involved in collating and normalizing and cleaning up. But we're starting to get a bigger continent-wide picture of kind of when lockdown interventions happened. And you can see some countries were basically immediate movers. And then, so for reference, again, these are all presented as sort of relative things rather than absolute times. We can see that there's a lot of slow movement through the sort of Central Southern Africa, sort of slow introduction of lockdown measures in West Africa and East Africa, but notably Kenya was an early mover. Okay, so of those places that had kind of were in the running, right? We're competing for having the first full-blown epidemics. We're seeing that now many of them have dropped off, and I think that is reasonably attributable to some of these early actions. And you can see places where they did not have particularly early action. So again, sort of emphasis here in West Africa. They're now above that 1,000 cases, reporting 1,000 cases threshold, even though early on they weren't sort of the early places with many, because they were late to the party, as it were, on the hitting the 10 cases and the 100 cases milestone. We might expect that perhaps they had later effective seeding, but because they had perhaps less quick interventions or possibly less efficacious interventions, it's not entirely clear yet how effective those interventions have been. But there may be a little bit of explanation as to why there are some some parts that have sort of rapidly moved to 1,000 cases. Now, of course, there could be a good explanation for it, which is they could have rapidly expanded testing capacity, right? That would be another way, and indeed a positive way to rapidly move to hitting these various milestones. And we'll talk a little bit more about why we don't really know that currently, and why it would be useful to do so. Okay, so that's sort of the big picture on what's going on with where there are cases, how quickly those cases have come along, and sort of where places appear to have maybe turned things for the time being, and prevented them from getting really out of control, and we may be able to pause for breath for a bit. Of course, we know a few other things about Africa. So on the left here, that's the world, right? And for the most part, our knowledge about SARS and SARS coronavirus 2, and particularly its severity, age-based susceptibility, comorbidities, et cetera, it comes from this picture on the left about the world. You may or may not be familiar, but things are very different in the Africa population period. And I know that we've been talking a little bit around this question of whether or not there's an age effect, or whether age is just a marker for accumulation of other comorbidities. Either way, we are going to see something very different in the African population versus the rest of the world. But of course, again, to emphasize, Africa is not a big unified pyramid. So if we look at Kenya, for example, which is going to be talked about in more detail next, this looks approximately like that pyramid that I just showed you. I mean, different aspect ratio, but it's the same sort of sharp triangle. But when we look at South Africa, there's quite a difference here. It remains sort of flat-ish, and then has a more traditional tail off. So it's more similar to the West. Now, most places in Africa are more like this, but there is a little bit of this out and about in the continent. Okay, then I wanted to emphasize one other piece of work that's come out of London School, and that's this look at what's going on with comorbidities. So in some sense, things look okay in Africa. It's a slightly lighter green than a lot of the rest of the world, and I think a lot of that is attributable to the generally younger population. But we sort of have to see, and I'll go into that a little bit more when I talk about what we would like to know more about. Okay, so we can combine these things. So early timing of cases, what we know about the population structure in Africa, what we know about how things proceeded in Africa, both in terms of those early outbreak dynamics and in terms of the timing of those interventions. Even though we don't necessarily know precisely what impact those interventions has had, we can make some assumptions about the sort of range of things that might have happened, and can think about going forward what impacts that can have. So I'm calling this, what can we model usefully based on what we have a fairly reliable foundation for talking about. So one thing we can do is certainly extrapolate early cases with those global trends that we've seen, and issue kind of a warning order. And this is some work that Julie and I and others at London School were involved with, and I'd like to think that it was part of the environment of warning bells that went off, that triggered some of those early interventions, and so helped avoid getting some of these actual outcomes. So these are the these are some projections we made about dates that, that places were going to hit 1,000 cases. You'll notice that by today, we were predicting actually that most places were going to, in a median sense, would have already reported 10,000 cases. And thankfully that hasn't happened. And I do think that interventions have played a role in that. Okay, and so then that gives you a picture that looks a little bit about, this is the map of the sort of timing of where things were going for those 1,000 cases. Now, you'll notice that most of these, some of these places do not yet have 1,000 cases. And of course, there were ones that at the time we made the projections, we didn't have any information about cases. But in terms of the distribution of kind of how hot it is, this compares favorably to that earlier picture of kind of what the distribution of cases are and kind of the trends of the timing to hit 100 and 1,000 cases. So we might have been off on the absolute level, but it seems like we're doing okay on relative timings. Okay, so then the other thing we can do is a whole bunch of what if scenarios. And so this is using the modeling framework that we've been using at the London School. It's an ordinary differential equation compartment model with stochastic elements, and we include, it has a bunch of age-specific parameters and including age-specific contact mixing, so sort of standard polymod stuff, but via the Prem et al. Synthetic matrices, since there isn't a whole lot of contact pattern data from Africa. Okay, so this is what, for example, this is what the unmitigated epidemic would have looked like in South Africa. Fortunately, we have not exceeded 1 million symptomatic cases in South Africa yet. I'm pretty sure. But that's probably based on their early lockdown stuff. And again, Julie's going to talk more about this. So we considered a bunch of different potential scenarios that the countries might use for planning purposes, and the links in there, and we can talk more about these in detail if you like. And sort of last but not least for the projections and the planning stuff, we're now getting into the business of using those detailed early introduction times and early interventions to think about what is happening with the epidemic across the entire continent. And so this is all very early work. I would have much prettier graphs for you. But this is basically every country in Africa under a particular scenario. In this case, it's the no mitigation scenario. And you're sort of seeing what the relative timing and peak size is for all of these places in terms of symptomatic cases. And there won't be too much difference in terms of some other metrics that we're interested in, like deaths, hospitalization, demand, that sort of thing. And then similarly, we're starting to think about if the interventions turned on at the time that we have data to indicate that they turned on. And then, for example, we consider, well, what if lockdown means that there's a net reduction in 20% reduction in those contact pattern, those contact matrices. But we've also considered, well, what if they were 40% or 60% or et cetera, and kind of trying to get our hands around what those interventions might have done, and if they did that, what that impact would be. But of course, this is all still very early work. And the next things that we're going to be looking at are kind of what happens when inevitably these countries start coming out of those interventions. Okay, so what do we need to be doing these things better? Well, I mentioned that we've got those synthetic contact matrices. They probably do not capture some important regional features. I mentioned earlier that, okay, we're modeling things as countries, at homogeneous countries at this point, but of course there are big urban-rural divides throughout Africa, and it may be pertinent to think about how there are sort of very different populations between those settings, and of course very different contact patterns between those settings, but there's just not a lot of good data on what that actually looks like. So then the other thing we need is epidemic metadata. So right now, the good, clean, convenient to use data sources that that are necessary to feed these models don't really have a lot of metadata information. So it's difficult to get things like, okay, these early cases were known to be travelers. You know, we assume that they were based on getting it elsewhere and bringing it back. We don't have things like, okay, this is when the cases were reported, but when was the sample drawn? When did the patients report onset? And you know, we know that that's not always going to be available, but there's certainly some of that exists, and it would be really useful to start feeding that sort of thing into the models. And of course, questions like surveillance trends, so test positivity rates, how many tests are being performed, all that sort of side information would be really useful perspective to answer these questions about, well, just how effective was the intervention. When we've sort of guessed at from the reporting data when introductions actually happened, but if we have some idea about testing rates or other indicators of underreporting, we might be able to do a better job of when things will start. Similarly, you know, intervention metadata. So what did compliance look like? What did uptake rates look like? Those sort of things. One of the things that is going to be super important, I mentioned earlier that that pyramid, that age pyramid, and then also it seems like the things that we know are risk factors do not seem to be super prevalent in the working age population there. But we also don't know things like what's the interaction with malaria going to be. So that's the kind of stuff where we really need that that detailed epidemiological data if it can be made available to make better forecasts. And then of course this is sort of out of our wheelhouse, but well, out of my wheelhouse, not our wheelhouse. But the question of, okay, so we're doing these interventions, we're doing some epidemiologically focused things. What impact are the interventions going to have on other elements of health? Nutrition, long-term savings, exposure to other risk factors for other disease. Okay, and so I planned to go short, but I have gone over. So I'm the worst, but we can have 2 questions now, or just proceed to the next talk.
Thank you very much, Carl. That was fantastic. At least you can operate Zoom. I'm very impressed with your red dot thingy. Do we have questions? While people are putting their hands up or writing them on chat, I'm going to ask Carl, the data access and availability for the slides that you showed about timing of lockdown and cases, essentially collated by Africa CDC or WHO, or has that been a lot of work to bring that together?
The intervention stuff. So there was originally a kind of volunteer, well, I say originally, the first information that I am aware of is associated with a volunteer effort coordinated out of Oxford for putting, basically citing these policy things, media reports about whatever, reports by embassies, that sort of thing. So that was coordinated there. I know that some of the other data is what's gathered by Africa CDC, WHO, Afro, et cetera. And now at sort of spearheaded by London School and others, but now available via big WHO, there's a consolidation of those several different streams, and they're trying to make it a consistently coded and clean and et cetera.
Thanks. That's really helpful. Bernard, you have a question.
Yes, I think you may have answered. It's about how much you trust the data, because every country, every continent has its own statistical systems. They are not always reliable. You don't have to go as far as Africa to find countries where I frankly don't really trust data at all. And I don't know much about Africa. So, you know, when a country like a typical African country reports something, is that really at all credible, given that enormous numbers of people live in very marginal situations, that, you know, young people get all sorts of things wrong with them all the time, and so forth and so on. Can you say a bit about that?
Yeah, so I don't think that I don't think the way to think about it is in terms of credibility per se. As you highlighted, more generally, all around the world, the data is imperfect and has a variety of imperfections in it. I think the question is more about utility. So is what we get from these places appropriately caveated in the way that you've described, right? That we know that it's incomplete, we know that it's underreported, we know that there may be issues with, so if we want to look at like risk factors or something, diagnosis of those risk factors. I think because we are aware of those things, that we can appropriately account for them in terms of uncertainty in what comes out of the models. And you know, and potentially you scrap a little bit harder for side data that will let you calibrate what you think about the raw data. So I think in general that it can be useful. I think the key is making it available, and well, yeah, that will be step number one, is sort of broad availability of the question, of the data in question. And once we've got that, we can start really doing the same sort of things that we have to do everywhere else in the world in terms of data interpretation.
Thanks very much. Thanks very much, Carl.